operating system. In today's session, we are continuing with the topic memory management. Myself, Kunal Panchal, your instructor. In today's session, we are going to discuss the fixed size partitioning scheme, or we can say fixed size partitioning policy. So, as we have discussed in the previous session, in the case of contiguous memory allocation, it has two types. One is fixed size partitioning scheme, and second one is variable size partitioning scheme. In the last lecture, we have already discussed the variable size partitioning scheme. Now, in this particular session, we are going to discuss fixed size partitioning scheme with example, and later on we will discuss the advantages and disadvantages of fixed size partitioning scheme. Okay, in the case of memory management chapter, so as far as operating system is concerned, with respect to memory management, there are two important responsibilities of operating system. One is the address translation and second one is memory allocation. So right now we are discussing memory allocation in detail. So in the case of memory allocation, there are two strategies. One is contiguous memory allocation and second one is non-contiguous memory allocation. Okay. In the case of contiguous memory allocation, as I told you, there are two strategies. Okay. One is fixed size partitioning policy and second one is variable size partitioning policy. Now, in this particular session, we are going to discuss fixed size partitioning policy in detail. So, as you know very well, when we are talking about contiguous memory allocation, it suffers from external fragmentation that we have discussed already in the previous session. So that things to keep in your mind. Okay. So when external fragmentation will come into the picture, when the requested process size is less than or equal to the available memory size, still we cannot accommodate that process into that memory block because that available memory is not available in contiguous fashion. So in that case, external fragmentation will come into the picture. Okay. So let us discuss fixed size partitioning policy. So in this particular scheme, what we need to understand, as we have discussed the various algorithms, or this is standard algorithms of variable size partitioning scheme, in which we have discussed first fit, based fit and worst fit algorithms. Same way, in the case of fixed size partitioning scheme, with respect to contiguous memory allocation, again we have same three standard algorithms. One is first fit, second one is based fit, and third one is worst fit. So let us discuss each algorithm in detail with the help of one example. So in the case of fixed size partitioning scheme, as we understood the basic understanding of fixed size partitioning scheme in the previous session, it suffers from internal fragmentation. What is internal fragmentation? Means in the case of fixed size partitioning scheme, the partition cannot be reused. Okay, suppose if my process request is, say for example 200 KB and I have one partition in memory which can accommodate 400 KB of size, so I can easily accommodate my requested process in that. Yes, But once you accommodate that 200 KB out of 400 KB, the remaining 200 KB would be wasted. And that wasted memory in that particular partition is nothing but internal fragmentation. So fixed size partitioning scheme always suffers from internal fragmentation. So let us discuss these three algorithms with the help of one example. So in this particular figure, you can see there are various memory blocks we have. Okay, means there are various partitions of total available memory, in which first partition is of size 200 KB, second one is 400 KB, third one is 600 KB, fourth one is 500 KB, fifth one is 300 KB, and last one is 250 KB. So these are the various partitions we have, and you know very well in the case of fixed size partitioning scheme, the partition will be performed priorly. It is not based on the requested process. Okay, it will be performed according to the available memory size. So this partition is performed priorly. Now, right now, we are at initial stage, so all the blocks are available to accommodate the process. Okay. So now let us discuss the various processes that we have. So P1, P2, P3 and P4. These are the requested processes that needs to be accommodated in this particular memory blocks. Okay. So the first process requires 357 KB, the second process requires 210 KB, third process requires 468 KB, fourth process requires 491 KB. So these requested processes are in sequential order, means P1 came first, then P2, then P3 and then P4. So you have to satisfy this request according to the order of these requested processes. Okay, so these are the inputs we have. Now let us discuss how the first fit algorithm works in the case of fixed size partitioning scheme by considering this set of inputs. Okay, so in the case of first fit, you can see the total available blocks would be accommodated like this. How it works? So as far as first fit is concerned, as we have discussed already in the previous session, how first fit algorithm works, it will starting its search from the initial position towards the first capable enough block through which we can accommodate the requested process. Till that block, it will continue to search. Once it identifies the first capable enough block, then it will stop searching and it will simply accommodate that process in that block. So let us discuss with respect to this example. So the first block of available memory is 200. Yes, but 200, the first process requires 357 KB. So 357 KB cannot accommodate in first block. So it will go to the next block. The next available block size is 400 KB. Yes, 400 KB can easily accommodate the P1 process. Yes, so the first fit algorithm will accommodate P1 process in the second block. Now, once P1 is accommodated, what is the remaining size of that particular block or is a partition? So 400 minus 357 is equal to 43. So 43, because it is fixed size partitioning scheme, the 43 would be wasted. So that's why I have denoted that 43 KB space in red color. Means this space cannot be further utilized. Okay, it is wasted. So that 43 is nothing but internal fragmentation. Clear? Same way. Now the second request came. It requires 210 KB. So again I will start the searching from the first block. So 200 is capable enough? No, it is not capable enough. So I will go to the second. Second one is already occupied. Now I will go to the third. Third means 600 kb. 600 kb can accommodate? Yes. Yes, so I will assign P2 process into the third block. Now, what is the remaining size of that particular block? 600 minus 210 is equal to 390. So 390 space in the third block is wasted. So again it suffers from internal fragmentation. The third request P3 requires 468 kb. Yes. So again we will start searching from the initial position. So first block contains 200 kb. Is it sufficient? No, it is not sufficient. So we will switch to second. Second is already occupied. Third is already occupied. Yes. Fourth one contains 500 kb size. So 500 kb easily accommodating. Can easily accommodate the process P3. So P3 would be assigned in that particular block. Now what is the remaining wasted space? 32 means 500 minus 468 is equal to 32. So 32 would be wasted in the fourth block of available memory. Okay, so these red blocks are wasted space and the blue ones are, we can say, available space. Okay. Now the last request came into the existence, which is nothing but P4 process. It requires 491 kb. So 491 kb can, again we will start searching from the starting point. The first 200 block cannot accommodate this request. Second block is already occupied. Third block is already occupied. Fourth one is already occupied. Fifth one is available. But size of fifth one is less than the requested size. So we cannot accommodate that process. Yes. Then we will switch to last block. Again, size of that available space is less than the requested size. So we cannot accommodate it. Yes. So 491 cannot accommodate in any of the available partitions. Okay. So this particular algorithm, first fit, suffers from external fragmentation because all the requests are not satisfied by having this set of block of memory. Yes, so the external fragmentation is there, and external fragmentation of how much size? 491 kb. Why? Why 491? Because it is a requested space. So when external fragmentation will come into existence, you can see in this particular figure we have more than 491 kb of space available in the memory. But why we cannot accommodate that request? Because that size is not available in contiguous fashion. So that is the reason why we cannot accommodate 491 requests in available memory blocks. Yes, because you can see 200 plus 300 plus 250 is larger enough to accommodate the requested P4 process, but it is not available in contiguous fashion, so that's why we cannot accommodate it. So that is the reason why the external fragmentation is 491 kb. Now this algorithm suffers from internal fragmentation as well. Yes, and what is the internal fragmentation? You can see in the red blocks, the size of the red block. You can sum the total red blocks 43 plus 390 plus 32 is nothing but the internal fragmentation of this particular algorithm with respect to these inputs. Okay, so this is about first fit algorithm. Now next one is base fit algorithm. So as we have discussed already, base fit works in a different way as compared to first fit algorithm. So how base fit works? So base fit will search all the available blocks priorly and it will accommodate the requested process into the available memory blocks by considering the smallest inner block which is capable enough to accommodate that request. So that block would be considered by the base fit algorithm to assign that process into that block. So let us discuss by considering the same set of inputs. So when P1 arrived, so P1 requires 357 KB. So it will search 200, 200 is not capable enough. It will go this one. It will search all the available blocks, and out of which one is smallest enough to accommodate that request, that will be finalized. So the 400 block is smallest one to capable enough to accommodate this P1 process. So P1 is assigned to second block of memory. Now what is the remaining size? 43. 43 is wasted because we are dealing with contiguous memory allocation, specifically in fixed size partitioning scheme. So we cannot reuse the partition. Yes, a single partition contains only one process. Okay, so that is the nature of this fixed size partitioning scheme. So 43 is internally wasted. Now next P2 can accommodate in the last block because smallest capable enough, the blocks we have to identify. So 250 is smallest capable enough to accommodate the process. So remaining wasted space is 40 because 250 minus 210 is equal to 40. So 40 is wasted. Then P3 came. P3 requires 468. So 468 can be accommodated. Yes, 500 and 600. We have no choice. So which one is smallest enough? 500. So 468 is given to the 500 block. And what is the remaining size? Remaining wasted size 32. So 32 is wasted. Okay. Now the last one is 491. So 491 can be accommodated in 600 block, or is a third block in memory. Yes. So 600 minus 491 is equal to 109. That space is wasted. Yeah. So in this particular algorithm, is there any external fragmentation? The answer is no. Why? Because all the requested process can accommodate in the available memory size. Okay, so there is no external fragmentation, but yes, there is a internal fragmentation. So how much internal fragmentation it contains? So 43 plus 109 plus 32 plus 40. If you sum these values, that is nothing but the internal fragmentation. Okay. Now, one more thing you have to keep in your mind: the base fit algorithm perform best or worst in the case of fixed size partitioning scheme. So, base fit algorithm perform best in the case of fixed size partitioning scheme. Why? Because you know very well the partition cannot be reused in the case of fixed size partitioning scheme. So, and the nature of the algorithm is what? It will accommodate the smallest capable enough block to satisfy that request. That scenario would be given, okay, as a priority in the case of base fit algorithm. So that is the reason why the base fit, because there are less chance, because we choose smallest capable enough block to accommodate any process. So the remaining space would be very small, and there are very less chance to reuse that size or this space. Yes, so that is the reason why the losses would be less in the case of base fit with respect to fixed size partitioning scheme. So that is the reason why base fit perform best in the case of fixed size partitioning scheme, but base fit perform worst in the case of variable size partitioning scheme. That things you have to keep in your mind. Okay, and the last algorithm is nothing but worst fit algorithm. So by considering the same inputs, let us discuss last one, worst fit. So what is the scenario of worst fit algorithm? Worst fit algorithm will consider the largest capable enough block to accommodate that request. Means suppose if we have two choices, 500 and 600 block, and requested process is nothing but 357. So I will consider the 600 block instead of 500 block because I need to consider the largest capable enough block to accommodate the request. Yes. So let us discuss this one. So in the case of P1, the P1 requires of 357 kV. So out of your available blocks, the 600 block is the largest enough block to accommodate this particular process. So 357, this process P1 is given to the third block in the memory, and the remaining size would be wasted. Means what? There is a large size of waste in the case of this first fit algorithm. So 243 is wasted in this case. Okay. Now P2 came. P2 requires 210 kV. So which one is largest capable enough? 500 kV block. So P2 accommodate P2 this particular block, and the remaining size which would be wasted is nothing but 290 kV. Yes, so it means what, there is a large size of waste in the case of first fit algorithm with respect to fixed size partitioning scheme. Now P3 came. P3 requires 468. So the available blocks are 200, 400, 300 and 250. So these four blocks are available, but none of them are capable enough to accommodate the process P3. So P3 is not accommodated. Now go to P4. P4 requires 491. So again 491 is not able to accommodate in these available memory space, or yes, in these available memory partitions. So P3 and P4 cannot accommodate it in any of the available memory block. So is there any external fragmentation in this case? Yes. Why? Because you can sum the value of P3 plus P4. 468 plus 491, that should be less than or equal to the available size. 400 plus 200 plus 300 plus 250. Yes, obviously it is less than the requested space is less than or equal to the available space. So that is the reason why there is a external fragmentation of 468 plus 491 size of memory. Okay. Is there any internal fragmentation? Yes, obviously. Large size of internal fragmentation as compared to first fit and the base fit algorithm, which is nothing but 243 plus 290. This is nothing but the internal fragmentation. So in this case, what is the conclusion of this story as far as worst fit algorithm is concerned? So worst fit perform worst in the case of fixed size partitioning scheme because we are considering the largest capable enough block to accommodate the request. Yes, so there is a big loss in terms of memory. So that is the reason why the worst fit algorithm perform worst in the case of fixed size partitioning scheme, and worst fit algorithm perform best in the case of variable size partitioning scheme. So these are the three different algorithms: first fit, base fit and worst fit with respect to the fixed size partitioning scheme. So I hope it was clear to you. Thanks for watching this video. See you in the next one.